In this video, I will go over the homework that follows the lecture 0.42 called the differentiation rules. And the main objective of this lecture is to refresh your memory on the four main differentiation rules that we use when derivative of a function, namely the linearity rule, the product rule, the quotient rule, and the chain rule. And let's get started. And I believe we're going to have one assignment for each rule. So this video may be a little lengthy, but it is what it is. So let's launch the first homework. And the first homework is covering the linearity rule, to summarize which I'll just write it right here. Derivative of the linear combination of two functions so derivative of a linear combination, it's the linear combination of the derivatives. And my computer is lagging a little here, but here's the rule. And let's see how we get to use this rule when finding derivatives. All right, so here's the function, and it's a polynomial function. So to find its derivative means this, but we're going to use the linearity property, so it's going to be same as this. And each of those we do know. So we have derivative of x cubed is 3x squared, derivative of x is just 1, and derivative of 6 is just 0. So the final answer is 21x squared plus 1. If you ever have to check your work, if you have doubts about whether you found it correctly, you can always just open Wolfram Alpha and just type derivative of and type your function. And I believe it will find the derivative. Now remember, in this class, you're allowed to use technology to perform pre-calculus tasks. Finding the derivative is not considered a pre-calculus task. If you once in a while check your work, check your progress with Wolfram Alpha, I probably won't be able to catch you every single time. So the idea is not to abuse technology and learn how to do most of the calculus tasks by hand first, and then use technology to support yourself in the process. So here we have another function. And finding its derivative, it's even simpler when it's a single function, because the linearity basically says you can take out the coefficient. So derivative of this is the same as derivative of this. And derivative of x to the 9 is simply 9x to the power 8. So the final answer is negative 45 over 2 times x to the power 8. And at some point you'll build enough confidence that you won't need to check every single answer with Wolfram Alpha. You'll just trust yourself. But it may take time to build that trust. So let's go to the next problem. At some point I'm not even gonna use scratch paper. X to the power 35 is just a power rule. It's 35x to the power 34. So the idea is that using the linearity rule, we can easily integrate, too soon for that, we can easily differentiate any polynomial function. That's the main idea. So here it's just going to be 36x to the power 5 minus 24x to the power 3. This is a good problem. It reminds you that the derivative of a constant is 0, and this expression, no matter how ugly it looks, it doesn't have a variable. And if it doesn't have a variable, it's a constant. And if it's a constant, derivative of it is 0. This is another polynomial, not even polynomial, this is like a power function, so very easy. Here we have a what looks like a rational function. It looks like it calls for the ratio rule, or the quotient rule, right? It's called. However, quotient rule is one of our least favorite rules. So if there is a way for us to avoid using the quotient rule, we would rather avoid it. So in this case, we can rewrite the rational function like this, because we have only a single term in the denominator. We can distribute it, and by doing so we actually simplify the original function quite a bit. It just becomes a polynomial function. And I think I'm doing something crazy here, right? So this should be 3x squared. So this should be negative 4/3 x to the power 4. This is 4/3 x to the power 3. And this is just negative x. And to find the derivative of this, we differentiate each part of the sum separately. So this is times 4x cubed plus 4/3 times 3x squared minus derivative of x is just 1. And that's the answer. We can simplify it. And that's it. Let's type the answer. So again, the idea is we don't like the quotient rule that much. So even though that was the first instinct, we probably would have run into much ugly expressions if we were to do the quotient rule here. So let's move that out of the way. Now, finding a derivative at a point is now consists of two steps. Step 1 is we find the derivative, And step 2, we evaluate the derivative at a point. So in our case, we're going to find the derivative first. I'm going to start cutting some corners here and just write the result to be efficient here. And second step is to evaluate the function at the derivative function at the given point. So in this case we have negative 64 minus 1/3, and I don't like, this is like a common denominator thing. It probably would have accepted if we just write negative 64 minus 1/3. I'm sure it will accept it. Yeah, but in real life, we do want to have one final answer, because you're not going to go to the Home Depot and ask them for 64 and 1/3. Well, in this case, actually, it looks like a mixed number, so that kind of works out. But in general, you wouldn't go to the Home Depot and ask for square root of 3 meters of 2 by 2, right? That just sounds incomplete. Same here, find the derivative, negative 7/3 x to the power 6 plus 1. So Newton usually gives you some problems from the previously completed objectives just to make sure you really understood it. So this problem seemed pretty straightforward. Minus 12x. And I don't want you to spend too much time looking through the Newton's solutions, because this is just a review, right? So we want to get through this as soon as possible. And if you have any questions, please do not hesitate to reach out. Now that we have completed the previous homework assignment, let's move on to the next one. And in the next problem set, we are going to work on the product rule, which is slightly different. So let's see what we have here. So as my computer is loading, let me remind you the product rule. And according to the product rule, the derivative of a product of two functions is the sum of the derivative multiplied by the other function, derivative of one function multiplied by the other function, and the function itself multiplied by the derivative of the other function. So this is what it looks like in Newton's notation. And let's see what this problem is asking us to do. So, well, this problem starts up really fast. So I guess we also need to be able to write the product rule for 3 functions, which makes the product rule for 2 functions look much easier once you see the pattern. And in our case, our function k is given to us as the product of x squared, g, and h. So k prime will be equal to derivative of x squared times gh plus x squared times g prime times h plus x squared times g times h prime. And instead of 2x, I guess it only makes sense if we just write, instead of x squared, if we just write the derivative 2x. So this is the derivative expressed in terms of x, g, and h. And now when we evaluate this derivative at -2, that means we have to plug in -2 for x. Everywhere we'll see it. So here we have g of -2, here we have h of -2, here we have -2 squared times g prime of -2 times h of -2. I'm running out of room here, so the third part of the sum will go here. -2 squared g of -2 times h prime of -2. And all of these outputs of both g and h and their derivatives at -2 are provided in the table. So the final expression will be 2 times -2 times g of -2, but g of -2 is 1. H of -2 is 0. Plus -2 squared. G prime of -2 is -1. H of -2 is still 0. Plus we now have -2 squared. G of -2 is 1. H prime of -2 is 3. So since h of -2 is 0, that means this whole thing is 0, this whole thing is 0, and the only thing that's left is the last expression, so the answer is 12. The first problem was pretty hard, kind of raised the bar really high, so you really need to know the product rule when you go into this homework. We have another one similar, so I'm gonna try to be very efficient here, and derivative of k is derivative of f, so it's gonna be 6x times g times h plus 3x squared g prime h plus 3x squared g h prime. And now that we're evaluating it at -2, we get this. And we have 6 times -2. G of -2 is -4. H of -2 is 1. G prime of -2 is -1. H of -2 is still 1. And here we have g of -2 is -4, and h prime of -2 is also -4. So doing all the math here, this is 48. The next term is -12. And the next one is well, this one is 12 and this one is 16. So whatever 12 times 16 is. And I wonder, well, let's just keep things simple. 48 minus 12 is 36 plus 12 times 16. I'm too lazy to reach for my calculator, so I'll just keep doing mental math here. 12 times 3 plus 16. I just factored out 12. So the final answer is 12 times 19, and which is 228. So these problems really test your understanding of or your ability to execute the product rule. In actual applications, it's easier. So this time the function, instead of being defined by a graph, it's defined, instead of being defined by a table, it's defined by a graph, but the idea is the same. So h prime will be equal to f prime times g plus f g prime, and evaluating it at 5 means we plug in 5 into f prime and g, and then f and g prime. And looking at the graph, we know that g of 5, g is the red graph, so at 5 it's equal to 1. F of 5 is the blue graph, that's 4. I don't know how that thing got here. F of 5 is 4. Now, derivative of f at 5, it's literally the slope of, because it's a linear function, so it's just the slope of that function at that point. So it looks like the slope is you're going down 2 and over 1. And the slope of g function at 5, it's the other way. You go up 2 and over 1. So the final answer is -2 plus 8, which is 6. And this is something that you would normally expect to be a standard product rule problem in calculus. So we have a function, and its derivative will be equal to and let me show you here how to actually organize your work. So here's our function, defined as a product of two functions. And you can identify this factor as f and this factor f as g. So by the product rule, we know that derivative of j is f prime g plus f g prime. So you just need to know all the ingredients of this formula, right? So we already know what f is, right? F is 4x squared plus 2. We already know what g is. G is 8x squared minus 6x. So now we just need to find f prime, which we learned how to find previously. So it's just 8x, and g prime, which is 16x minus 6. Now we have all the ingredients. We can continue with this, with answering this question. So it's going to be f prime, which is 8x, times g, which is 8 squared minus 6x, plus f, which is 4x squared plus 2, times 16x minus 6. And I believe if you type this in Newton, it will accept the answer. However, let's go ahead and simplify this. But usually that's where most of the mistakes occur when we try to simplify something. 48x squared plus, here we have 64x cubed plus 32x minus 24x squared minus 12. Combining the like terms, we get 128x cubed minus 72x squared plus 32x minus 12. 128x cubed minus 72x squared plus 32x minus 12. And I feel like we've done something like this before, so I'm just going to skip this one. If you have questions, just reach out to me, but I don't want to spend too much time on this type of problems. Another one. And let's do this one. So the derivative of h is the f prime g plus f g prime, but so derivative of h evaluated at 7, it's going to be f prime of 7 times g of 7 plus f of 7 times g prime of 7, and all that information is given to us. So f prime of 7, that's not given, we have f is actually given to us, right? So f is negative 2x squared minus 9, so f of 7 is negative 98 minus 9, so negative 107. And f prime is equal to negative 4x, so f prime of 7 is negative 28. So now we know all the ingredients, so we can continue with this calculation. F prime of 7 is negative 28. G of 7 is given to be negative 2. Plus f of 7 is negative 107. And g prime of 7 is 6. Now, previously I said I didn't want to reach out for my calculator this time. I also feel lazy, but I was going to show you another way of doing this. Hopefully I got this one right. So what's 56 minus 42? It's 14. So that should be the answer. However, if you're not sure at your basic arithmetic skills, what I would suggest is opening Desmos. And Desmos has this ability to compute numerical expressions, so you don't have to use it just for graphing. You can just type exactly what we have here and see what the right answer is. So negative 28 times negative 2 plus negative 107 times 6, and that's the answer. So that's another way to use Desmos. So this is another problem that we've seen before, so I'm just going to show you an example here. It's very similar, so let me skip this one. And we are done. So we reviewed the product rule. The next rule for us to review is the quotient rule. My computer is incredibly slow today. Hopefully the quotient rule won't take too much, because the rule itself is very similar to the product rule. The numerator of the expression is very similar to what we see in the product rule, except it has the negative sign. But it's the quotient rule, so we also have g squared in the denominator. This is the quotient rule, and let's see what we have here. We have derivative of h, and in this case it's actually given to us as f divided by g, so we can just take advantage of what's already written. And when you evaluate it at -1, that means we need to find f prime of -1, g of -1, f of -1, and g prime of -1, and divide all that by g of -1 squared. And in order for us to be able to compute this expression, we have to know f of -1. So what's f? F is 2x squared plus 2. So the derivative of f is 4x. So f of -1 is 4, and f prime of -1 is -4, and it's given that g of -1 is 2, and g prime of -1 is 9. So now we can plug everything in. So we have f prime of -1, -4, times g of -1, 2, minus f of -1, 4, times g prime of -1, 9, divided by g of -1 squared. So the answer is -11. This is what a standard problem from Calculus 1 looks like. We're going to define h as a quotient, and we're going to identify the numerator as f and the denominator as g. So f is 6x, and therefore f prime is 6. G is 2x squared plus 9x minus 6, and therefore g prime is 4x plus 9. And now to find the derivative, we're going to use the f prime g minus f g prime divided by g squared. So in our case, f prime is 6, g is 2x squared plus 9x minus 6, minus f times g prime, and all that divided by g squared, which is 2x squared plus 9x minus 6 squared. And of course we can combine the like terms in the numerator. The denominator is as simple as it gets, unless you want to try and factor this, which I wouldn't recommend. And here we have 12x squared minus 24x squared, so we have negative 12x squared. We have plus 54x minus 54x, that's gone, and we have minus 36. So here we can take out negative 12, and we end up with something that looks quite nice. And let's type the answer. We have negative 12x squared plus 3 divided by 2x squared plus 9x minus 6, all that squared. And we are done with this problem. We still have quite a few more problems, so maybe at some point I'll just start skipping them just for the sake of saving time, because my computer is not liking this today. So let's find h prime of 2. So we start off by finding the derivative. So derivative is equal to the derivative of the numerator, which is 12x. And also we have a negative in front of the whole thing, right? So negative can be factored out at the very beginning. So now we have the derivative of the numerator times the denominator. Minus the numerator times the derivative of the denominator. And all that divided by the denominator squared. And we're going to simplify this. But at the same time, we don't have to, because remember, we're looking for h prime evaluated at 2. So we don't need to simplify it, we just need to compute it. So let's just, for the sake of saving time, let's just throw the number 2 in there. And this is just a basic math. If you are worried that you're not going to be able to compute this by hand, then you can just throw this in Wolfram Alpha or Desmos. Let's do it. So we have 24 here. Expression in parentheses is equal to 16 plus 12, so it's 18, minus 24 times 22, and we divide all that by 18 squared. So we minus, let's take out 24 there. So we have 18 minus 22, that's just negative 4 divided by 18 squared. But 18 can be written as, I mean, here, I'm just being lazy. We know that 4 and 18 have 2 in common. We know that 24 and 18 have 6 in common. And the final answer is 8/27. So getting 3 questions in a row done pushed us from 20% progress to 56% progress. So make sure you're not just guessing, but putting your best foot forward with every problem. Here we have what do we have here? We have like a combination of rules here. So to find h prime, we're going to use the linearity first. So h prime will be the derivative of this. So by linearity, we take this and separate. And derivative of 3 over x squared, we don't want to use the quotient rule for this because derivative of 3 over x squared is same as derivative of 3x to the power negative 2. Which is, by the power rule, it's negative 6x to the power negative 3. And here we just do the quotient rule. So f prime g minus f g prime divided by g squared. So evaluating everything at 3 means we plug in 3 in there, and f prime of 3 is 1, g of 3 is negative 4, f of 3 is negative 4, and g prime of 3 is 3. And we divide all that by g at 3 squared. Now it's just a simple arithmetic expression, so we have negative 6 divided by 27 plus we can reduce one of these negative 4s. So what we have at the end is 1 minus 3 negative 2 divided by negative 4. And maybe we can just, so reducing it by 3, so we have negative 2 over 9 plus 1/2. And this is just addition of fractions. Common denominator is 18, so negative 4 plus 9 over 18. So the answer is 5/18. And looks like we're done with the quotient rule. So the only rule that we have left is the chain rule, and it's one of the hardest ones anyway. So I hope you stuck around and you still paying attention, because this is the one where most of the students start struggling. So while it's loading, let me remind you what the chain rule looks like. It tells us that f of g, if you ever have a composition of two functions and you need to find the derivative, it will be the derivative of f evaluated at g times the derivative of g. And if you have more than two functions, it's more of a process than a formula. So you take the derivative of the outer function, plug in the inner function, then multiply it by the derivative of what you just plugged in, and if what you just plugged in was another composition, you just continue the process. So right away we have a problem that's not just a chain rule. So it's first of all a product. So let's take a look at what we have here. We have a product of two functions. And first of all, you have to identify this as a product, right? So we do have this f times this g. So according to the product rule, it will be derivative of h will be the derivative of the product. So it's going to be f prime g plus f g prime. But, well, no buts, but we don't necessarily know right away what derivative of f and g is, right? So here we have f as negative x squared minus 1 squared. And here we're going to do g function. G is equal to the square root of 2x squared plus 1. And the question is, we need to find the derivative, right? So here we need to find f prime, and here we need to find g prime. But each of these two functions is actually a composition of other two functions. So on the left side, f is the composition of two functions, u and v. So if I were to write f as the composition of u and v, what is my u and what is my v? Well, u is the outer function, so u is the squaring part, and v is what's inside of the square. So you can easily check that for this u and v, u composed with v will give us f. Therefore, by the chain rule, f prime is equal to u prime evaluated at v times derivative of v. So let me move this out of the way, because we're gonna need the derivatives of both of them anyway, so we might as well find it. What's u prime? U prime is 2x. What's v prime? V prime is minus 2x. So f prime will be equal to u prime, which is 2x, but instead of x, I'll be plugging in v. So v is negative x squared minus 1, and v prime is negative 2x. So that's the derivative of f. Similarly, we can find the derivative of g. G can be defined as a composition of two functions, the radical function and the polynomial function. So let's call it radical function of polynomial function. So my radical function is the square root of x, and my polynomial function is the actual polynomial here. So the derivative of the radical function is 1 over 2 radical x, and derivative of the polynomial function is 4x. So to find the derivative of g using the chain rule, we're going to take the derivative of the outer function, plug in the inner function, and then multiply by the derivative of the inner function. And here's what it looks like. So derivative of r is 1 over 2 square root of x, but we're going to be plugging in p in there, and we multiply it by p prime. So that's again the chain rule. This is kind of what we're practicing here. So the final answer will be 1 over 2 square root of 2x squared plus 1 multiplied by 4x. Now we're going to put it all together. Using the product rule. So the final answer is the h prime of x will be equal to the f prime. F prime is this right here. We can simplify it further probably. We can take out all the negatives and write it as 4 times x squared plus 1 times x. So derivative of f is 4 times x squared plus 1 times x times derivative of, not derivative, but the g itself. So g is the square root of 2x squared plus 1 plus f, which is the negative x squared minus 1 squared, times g prime, which we found to be right over here. So this 2 and this 4 can be reduced, and then 2x can be written in the numerator, so it's 2x over square root of 2x squared plus 1. And that's the final answer. Now, it can be reduced, simplified, but that's not the purpose of this exercise, so let's just start typing it. And yeah, we assume it understands the implicit multiplication there, so let's submit this. It wasn't an easy problem, but it wasn't because of the chain rule, because we had to combine two chain rules with the product rule. That's what made this problem really hard and time-consuming, but the goal here is to just practice the chain rule. So this is like a standard problem on the chain rule. So let's break this down into smaller steps. So we have a function y defined as a radical of a polynomial. So if I want to write it, first I want to write it as a composition of two functions, f and g. So I need to know what is f and I need to know what is g. This is where your understanding of composition as an operation comes really handy. Your f is the radical function and your g is the polynomial function. So this is how we decompose the y function. Now once you know its decomposition, you should be able to know the derivative of each function. And now we can apply the chain rule. So derivative of y is derivative of f with g plugged in multiplied by the derivative of g. So derivative of f is 1 over 2 square root of x, but remember, we're not plugging in x, we're plugging in g. So this is what the chain rule looks like in this case. 1 over 2 square root of negative 2x cubed minus 3 multiplied by g prime. So that's the answer to this question. And of course we can reduce it by 2, so in the numerator we have negative 3x squared divided by square root of negative 2x cubed minus 3. Hopefully from now on the problems will be just like this one. And if I see another one like the first one, I will just skip it because it's just not worth it. We have a function defined by a table, and here we have h of x given as the quotient squared. So if we want to see it as a composition of two functions, and we cannot use f and g because f and g is already used, so I'll use u and v. Then my u as the external function has to be the square, and my v as the internal function, the one that goes in, has to be g over f. So the derivative of u is 2x, and the derivative of v is the quotient rule. So it's g prime f minus g f prime divided by f squared. Notice how this is not the same as f over g, so I had to adjust the quotient rule to reflect that change. But now if I'm looking for derivative of h, it's going to be the u prime evaluated at v times v prime and evaluated at x, and u prime at v, it's 2 times x, but instead of x I'll be plugging in v, and instead of v prime we're going to plug in well, let me just put v prime over here, and now we're going to plug everything in. So 2v means we have 2g divided by f times v prime means we plug in that formula. And in this case we evaluate everything at 0, so everything has to be evaluated at 0. So 2 times g of 0 is 1, f of 0 is 1, g of 0, g prime of 0 is 1, f of 0 is 1, g of 0 is 1, f prime of 0 is 3, and f of 0 is 1 squared. So the final answer is -4. This is a standard problem from Calculus 1 covering the chain rule, so you probably had something like this on the final exam. So let's again, if you need help with the chain rule, let me break it down for you. When you're looking at a function, you have to first identify the composition. In this case, we have two functions. F is the power function raising to the power -4, and g is the polynomial function inside of the parentheses. So we know how to find derivatives for each one of them. And just want to remove that minus here. And now we're going to find y prime using the chain rule. So it's going to be the derivative of f evaluated times g prime evaluated at x. F prime is -4, x to the -5, but remember we evaluated at g, so we're going to be raising g to the power -5 and multiplying it by g prime. So the final answer is -4 2x to the 4 minus 3 to the power -5 times g prime, which is 8x cubed. So we can rewrite it as a fraction. That looks better than negative exponent. So fraction -32 x to the power 3 parentheses 2x to the power 4 minus 3 to the power 5. These controls are not intuitive at all. On the right side, I mean, like I'm tired of zooming in and zooming out of this canvas pane. All right, so we have, this is a good one. For this problem, we just have to stick to the rule, and we have a composition of two functions. Here we have a composition of g, and the inner function is a product. So if we're gonna write it as a composition, my external function is g, and my internal function is v, so it's the product, and the derivative of u is just the derivative of g, but derivative of v by the product rule is going to be the derivative of the first term, which is 1 times f of x plus x times f prime of x. And now if I want to find the derivative of h, it's going to be the derivative of the outer function evaluated at the inner function and multiplied by the derivative of the inner function. And in our case we have u prime, it's the g prime, but g prime will be evaluated at v, but v is x times f of x, and all that's going to be multiplied by v prime, which is f of x plus x times f prime of x. So let's plug everything in. We're gonna plug in 3 in there, so we have g prime evaluated at 3 times f of 3 times f of 3 plus 3 times f prime of 3, and let's compute this. Here we have 3. What's f of 3? F of 3 is 1, and f prime of 3 is 4. So at the end of the day we have a g prime of 3 times 13, and g prime is 2. So the answer is 26. Not an easy problem. I can totally understand why anyone would get frustrated with it, but again, as a Calculus 2 student, we are capable of managing through all the pain of doing Calculus 1. H of x is equal to so this is an application of a quotient rule. But as you're applying quotient rule, you realize that you're going to need the derivative of g, but g is actually a composition of u and v, where u is the radical and v is the polynomial. So meaning that if you're looking for the derivative of g, you have to do derivative of u evaluated at v and multiply it by v prime, which in this case means you're going to take 1 over 2 square root of, but instead of x I'm going to plug in v and multiply it by the derivative of v. So continuing with this computation, we get 1 over 2 square root of v, which is 3x cubed minus 9, multiplying by v prime, which is, I'll just write it in the numerator, 9x squared. And now we have all the ingredients, and now we are ready to find the derivative of h. So h prime will be equal, by the quotient rule, f prime g minus f g prime divided by g squared. So f prime is 9, g is square root of 3x cubed minus 9 minus f, which is 9x, times g prime, which is 9x squared over 2 square root of 3x cubed minus 9, and all that divided by g squared, which is simply 3x cubed minus 9. And of course this can be probably simplified and reduced, but that's not the purpose of this exercise, so we're just gonna copy everything over. And I can't wait for this homework to end, because we're literally reviewing all the derivatives in one long, well, this is a one long video, but you don't have to take the homework in one sitting, but I have to sit through this, so I'm tired. So if you are tired, go take a break. I'll be here when you get back. 3x cubed minus 9. And maybe next time I'll zoom in so you can see better. Can I zoom in? Let's see. There you go. Let's submit. And I was hoping it will go all the way up, but nope. We still have to do one more objective. Okay, so derivative of h. Derivative of h is equal to x to the 4 plus p of x to the power 3, and we can view it as a composition of two functions, f and g, where f is the cubing and g is the what's inside of the parentheses, and the derivative of f is 3x squared, and the derivative of g, by the linearity, it's 4x cubed plus p prime x. And now by the chain rule, we're gonna get the derivative of f evaluated at g times g prime evaluated at x. So in our case it will be f prime, so it's going to be 3x squared, but instead of x I put g. So plugging everything in, we have what? 3g squared means x to the 4 plus p of x squared times g prime, but g prime is 4x cubed plus p prime x. And the question is to evaluate this at -1, so we just plug -1 in there. P of -1 is -2. And p prime of -1 is 3. So we just need to compute this. So 3, this is 1 minus 2, -1 squared is 1. -1, -4, -4 plus 3 is -1. So the final answer is -3. So we should be able to do the same task without a function being given to us explicitly. So finding the derivative of f and g, again, means by the chain rule, it's derivative of f evaluated at g times derivative of g evaluated at x. So if we evaluate derivative of u at 5, that means we have derivative of f evaluated at g at 5, and we multiply it by the derivative of g at 5. So we should be able to read all that information from the graphs on the left side. G of 5 is 3. G prime of 5 is the slope of the tangent line. It's a linear function, so the slope is 2. And we need to compute f prime of 3. So at 3, the f has the slope -1. So the final answer is -2. You cannot see that function u here on the graph, so don't look for that. This question has to be done like this analytically, just by sticking to the rules of the differentiation and understanding how functions are defined, how information is provided to you. In this case, we're doing the same thing but in Leibniz notation, so which is just an alternative way of writing it. Again, what do we have here? So we're looking for the dy dx. I see. Y is equal to 5u to the power 4 plus 2, and u is equal to 3x cubed, meaning that my actual function is here, let's say f of x, like the original function is actually this, right? So I have 3x cubed to the power 4 plus 2. So this is the function that we're trying to differentiate. So the derivative will be the derivative of the outer function, which is 20u cubed, and the derivative of the inner function is 9x squared. So the derivative of f will be the y prime evaluated at u times u prime. But they want us to use Leibniz notation. But again, by now you should already have your preferred notation, so just stick to it. There's no need to change it. And in this case, we have 23x cubed times 9x squared. All right, what's going on with the progress bar? It seems like hopefully this is the last problem. And so in this case, the function is given, and we are practicing here a basic skill of decomposing a function. So we clearly see this is as a composition of two functions. If we use letters f and g, the outer function f, is that what they want? No, they want f and u. So if they want f and u, then the outer function is the f and the inner function is u. So in this case, the outer function is the cubing. So we write it as x cubed. And the inner function is what's inside of the parentheses. So 2 minus 2x to the power 4. So that should be the answer. And with their hint, it's hard not to answer it correctly. They want us to write y as a function of u, so they want us to probably put u in here, not x. Let's see. Yeah, that's it. And one more. I don't know why I wrote this. The function is given. And again, if we're going to write this as a composition of two functions, the outer function is the cubing, and the inner function is the polynomial. And to find the chain rule, we need these ingredients. And putting it all together gives us the following result. So we have derivative of f evaluated at g times g prime. But derivative of f is 3x squared, so it's 3g squared times g prime. And 3g squared is going to be negative 3x to the power 5 minus 3 squared times g prime. Of course, we can simplify it, but that's not the purpose of this exercise. So let's see, negative 45 x to the power 4 times negative 3x to the power 5 minus 3 squared. And this is the last problem on the chain rule, and it's also the last problem in this homework. This was a pretty extensive review of the derivatives. If you have any questions, please feel free to reach out.